Probably the most important thing in an electrical system is stopping the power flow when something goes wrong. And that's the job of breakers. Let's take a look at what people used before breakers existed, how they evolved over time, and why they're even necessary in the first place. So welcome back to the lab where our opinions cannot be bought. We don't only exist to give you honest feedback on products and save you money where we can. We also want to make solar and electricity simple for you guys. You can support the channel for free by subscribing, and you can watch some of our other videos to help you learn. Before we jump into why you should know the importance of breakers, we're going to give you guys some context for why they even came about in the first place. When electricity started entering homes in the late 1800s, protection was kind of an afterthought. Imagine the Wild West for electricity. Early wiring was cloth insulated, usually ungrounded, and often much smaller than what the load demanded. When too much current flowed, there was nothing to trip the power. The wires just heated up. And when those wires began to heat up inside of walls, buildings began to burn. And the first real attempt at protecting these wires was the fuse. What a fuse is it's basically just a deliberate weak point in your electrical system. There's many different types. You often see them in cars. You might see them in old cottages with glass bulbs. And inside there's a little filament that's basically a little mini wire, which is a weak point in that system. And when that system gets too hot, that weak point burns up really quick, and it basically stops the other wires that are in your walls from starting an electrical fire. But the problem with fuses is once they would blow, you would have to actually fully replace them, which costs money. And the way to get around paying extra for these fuses was that people would just start simply installing larger fuses so that they wouldn't trip as often. People also even did crazy stuff like putting in quarters, pennies, electrical wire, anything that was much larger and wouldn't actually burn. Obviously, these fuses were supposed to be rated for whatever size wire or whatever gauge wire you had in your walls. Fuses were definitely a good start, but house fires remained a problem. Not because the fuses didn't work, it was just how people were trying to get around the cost of constantly replacing them. As electricity spread and more people welcomed it into their homes, fuses did get better and amperage did become more standard. Screw-in bases were designed to correct the incorrect fuse sizing, cartridge fuses were developed for higher fuse applications, and the metal that's inside of those fuses became more predictable and reliable. Even today, we still use fuses, and that's because they actually react very reliably and quickly. In fact, I actually talked to an electrician who said that he prefers fuses because they burn up so fast. But there is still that one major limitation. Once they blow, they're done. You throw them out in the garbage and you gotta put a new one in. And that limitation is what opened up the door for breakers. And the first reliable circuit breakers actually were developed pretty early on, in the early 1900s. But they were mainly used in industrial environments, which is why you probably didn't see them around in your homes till much later on. But early breakers were big, heavy, and entirely mechanical. Some were filled with oil, some relied on air gaps, and many of them were just designed for industrial rooms instead of residential panels. By the mid-20th century, the breakers started being more designed towards residential applications. And this is where the thermal magnetic breaker became standard in homes. It's pretty close to the same design as the originals. So a lot of people kind of get this wrong. There's a misconception on what the purpose of a breaker is. A lot of people think that these are supposed to protect an appliance or protect people. And in a roundabout way, they are obviously to protect people, but not for the reason that you think. So their real job is just to protect the wiring. They do this by solving three main problems. It's not just one mechanical thing that's happening inside of this. The first problem is long-term overloads. This is where too much current flows for too long. The second one is short circuits, or dead short is what you've probably heard. That's where the current takes an unintended path. And it also protects against catastrophic equipment failure. So all that's great, but how does this actually work? So inside of a modern breaker, there's two trip mechanisms that are both happening. The first one is thermal protection. Imagine you have something like an oversized heater that's rated for a 20 amp. Or let's say you do have a 15 amp space heater, but you hook up something else on the same circuit. These space heaters are pretty much designed to almost max out that 15 amp circuit. So imagine you have your space heater, you're powering a TV off that circuit, and then you plug your phone in. It's not gonna immediately trip it, but if it's teetering around that 15 amps, or maybe it goes up to 15.5, 16, over time, it'll slowly warm up an element that's inside of this until it is malleable, and then this breaker will trip. And the second one is magnetic protection. In a short circuit or a dead short, this is where the electricity spikes extremely fast. It's almost like an explosive amount of power. Imagine you're basically taking a hot black wire and then you touch the white wire or you touch the ground. You're gonna have a crazy amount of power, a lot more than 15 amps, happening in a very short amount of time. It might even cause arcing. In this situation, there's actually a magnetic component inside of it. When a lot of that power is created, it's going to make a magnetic field that trips the breaker. These contact points basically snap open and it breaks the circuit. And then you have to go back to your panel and flick it back on. And this solved the problem of replacing the fuse. Basically, you have a reusable breaker that you can use over and over and over again. So the pricing component of this problem was solved. It's more money up front, but it was only a one-time fee. Right now, these 15 amp breakers are actually not that much money though. You can pick up some of them at our store for about 13 bucks. But when you get into specialized ones like GFCI or arc fault, you're looking at $100 more for the exact same thing. But that's because those things solve a completely different problem. An arc fault is basically detecting arcing that's happening in your electrical system, which will trip a lot faster. If you don't know what an arc fault is, if you've seen anybody welding, basically they have arcs of electricity that are flowing and those arcs are extremely hot and it's actually what's melting the metal and creating the welds. That can actually happen unintentionally with your electrical wires. I remember one time I was extremely lazy and I didn't want to go and turn off a breaker. I shouldn't have done this, but I knew that if I took the black wire and just touched it to the ground, I would trip the breaker. Instead of just walking to the other side of the house, I thought I'd do that instead. And I didn't close my eyes. I touched the white wire and there was a massive white orb. It basically blinded me for probably like 10 seconds. But essentially that is what an arc is. You have a mini arc of lightning that's happening, which can easily start a fire. If that's in a flammable location, like in a bedroom or even in your walls, and again, it's not enough power to trip the breaker, that could keep on happening until a fire ignites. That arc fault breaker is specifically designed to detect those arcs and shut the power off. The other breaker is a GFCI one. And just to explain that super quickly too, a lot of people will actually say, oh, well, if we somehow get electrocuted or there's a problem, you don't have to worry about it. There's a breaker and it'll trip off before anything bad happens. That's also not true. These are not designed to protect people. Like I said, in a roundabout way, they obviously are, because you don't want your wires to start a fire. But the GFCI is specifically designed to protect people. Just as little as 0.1 amps can actually stop the heart of a person. Let's say that you're using 100 volts or higher. That's enough to push the electricity through you. And like I said, 0.1 amps is enough to stop a heart. A GFCI basically has a little computer inside of it. And what it's doing is it's sending power out and then it measures how much power is coming back in. If it detects that there's an imbalance, a very small imbalance, it basically decides this power must be running through something else. It could be a person. And so it trips the breaker. That's why they're installed in places like wet locations, around a sink. If you plug in your hair dryer, you're in a more dangerous situation where power could be flowing through you. And that's why you see so many GFCIs in homes nowadays. Arc fault breakers are a lot less common, although in many situations or in many jurisdictions, they're actually required now to pretty much power every single thing in your house. It used to be mainly in only bedrooms, but now they want to see that in pretty much every single outlet, excluding a few things. In our area, that would be excluding vanity outlets, kitchen outlets, the main fridge if it's on one breaker, any lights if they aren't connected to the same circuit as the outlets, a sump pump, you're only allowed one, and finally connections for appliances like your oven. And that's because it's a more permanent setup. Basically every single other outlet in your house needs to have an arc fault breaker. At least that's what it is where we live. The good news is if you have modern power stations or inverters, there's gonna be breakers and overload protection all built in. But we've had systems before where they recommend to install these breakers or disconnects somewhere in line. And if they do that, absolutely follow their rules. They're there to protect your system and your house. But anyways, that's the end of this video, guys. If you liked it, subscribe down below, give us a thumbs up, and we'll see you guys in the next one. Thanks so much for watching. Peace out and stay charged.